Hi students, in this video we are going to discuss some important numericals. Numerical. A metro train accelerates uniformly from rest. From rest to a velocity of 180 kilometers per hour in half minute. Find the value of acceleration find the value of acceleration of the train. Solution. Dear students, once again I am repeating the question. Please listen carefully. A metro train accelerates uniformly from rest to a velocity of 180 kilometers per hour in half minute. Find the value of acceleration of the train. That means our aim is to find acceleration of the train. Let's go for discussion. Here final velocity V is equal 180 kilometer per hour. That is equal 180 into 5 by 18. That is equal 50 meter per second. And from first equation of motion, V is equal U plus AT. That means 50 is equal to 0 plus A into 30. Therefore, A is equal 50 by 30. That is equal 5 by 3 meter per second. Therefore, A acceleration is equal to how much? 5 by 3 meter per second. Like that we have to solve the numerical. Now we are going to discuss another numerical. Now we are going to discuss another numerical. A metro train accelerates uniformly from rest from rest to a velocity of 180 kilometers per hour in half minute. Find the distance covered by the train in this time? Question mark. My dear cadets, once again I would like to repeat the question. A metro train accelerates uniformly from rest to a velocity of 180 kilometers per hour in half minute. Find the distance covered by the train in this time. This is the question. Dear students, here we have to find two important points. One is acceleration and the second one is the distance covered. These 2 points we have to solve. First point, step solution. Step 1, to find the acceleration. Okay, that means initial velocity u is equal to 0 and time t is equal to 1 by 2 minute, that is equal to how much? 30 seconds. Okay. Now final velocity V is equal to 180 kilometer per hour, that is equal to 180 into 5 by 18, that is equal to 50 meter per second. Okay, that means we find final velocity. How much? 50 meter per second. But from first equation of motion V is equal to U plus AT, that means 50 is equal to 0 plus A into 30. Therefore, A is equal to how much? 50 by 30, that is equal to 5 by 3 meter per second square. Okay, now step 2. That means to find the distance covered second point. That means what is the second point? Our aim is to find the distance covered. That means total distance covered. Total distance covered by the car during the given time. During the given time is given by what is the equation? From second equation of motion, we have to write S is equal to ut plus half a t square. That means what is initial velocity? 0. 0 into what is the time? 30 plus 1 by 2 into what is the acceleration? 5 by 3. 5 by 3. Please observe carefully here. We already derived 5 by 3. So 5 by 3 into 30 whole square. Okay. Therefore S is equal how much? 750 meters. Like that we have to solve the numerical. Now we are going to discuss another numerical. Numerical number 3. An Airbus runs on a runway from rest. Its final velocity is 810 kilometers per hour. Full stop. The length of the runway is 1000 meters. Calculate the uniform acceleration of the Airbus. Dear students, once again I am repeating, an Airbus runs on a runway from rest. Its final velocity is 810 km per hour. The length of the runway is 1000 meters. Calculate the uniform acceleration of the Airbus. This is the question. Now we have to solve this question. First write the given data. Given initial velocity u is equal 0. Final velocity v is equal 810 kilometers per hour. We have to convert kilometers per hour into meter per second. Therefore, v is equal 810 into 5 by 18. Therefore, V is equal to how much? 225 meter per second. That means the final velocity we convert into meter per second. Now, distance covered. Distance covered. Distance covered. That is equal to, yes, that is equal to length of runway. That is equal to, yes, how much? That is 1 kilometer. Now tell me, 1 kilometer is equal to how many meters? 1000 meters. Now from third equation, of motion, V square minus U square is equal to 2AS. That means, what is V square? 225 whole square minus initial velocity how much? 0. 0 square is equal to 2 into what is acceleration? We don't know. What is distance? 1000 meters. Therefore, 2000 into A is equal to 50,625. Therefore, acceleration A is equal to 50,625 whole by 2000. How much? 25.31 meter per second. That means the acceleration of the Airbus is 25.31 meter per second square. Like that, we have to solve the numericals. I hope you understood these 3 numericals. Thank you very much for watching this video.